So today we're learning about anti-differentiation, right? So you guys are probably like masters of differentiation by now. Yeah, you can derive basically any equation that you need to do in unit 3, which is like just the basic one, and then the trigonometry, sine, cos, and then e to the power something, right? And then ln. So you can differentiate those. Now can you do the reverse of it? Can you do the reverse? All right. When you have an equation, can you figure out how to get that derivative, right? How to get the original equation. Okay. All right. Let me go through. Okay. Let me go through a few ideas for you guys. 9b. All right, guys, have a look. I will give you guys a few the main idea behind today's content. Okay. So I will have an equation called, I'll call that the original equation, right? The original equation and then the derivative equation. Actually, I'll write it this way, original and then derivative. Okay. So far, you guys have been deriving something that's, like, okay, let's start with some basic derivative. So let's say the original is like x squared, then derivative would be 2x, right? Easy enough. Yeah, and the pattern is you times the power down, you drop the power by 1. Okay, so if I were to write the pattern here from left to right, it is times power, and then power minus 1. Okay, right? If we were to follow this pattern, then we'll get something like, let's say x to the power 4 plus x to the power 3. When you derive it, you times the power down, 4x, and drop the power by 1, power 3. Plus, same thing, 3x squared. Basic stuff.
Wow.
Right? Same pattern. Now, what if I give you not the original, but I give you the derivative? And I say that the derivative is x cubed plus x squared. What do you think is the pattern to go backward? I know that forward is this pattern, right? But now we're going backward from right to left.
X.
What do you think? I'll tell you guys. There are 2 steps related to the 2 steps here, right? Very similar to these 2. But can you guess what the 2 steps are?
Well, like, you'd have to add back to the power.
Yes, so power plus 1.
That doesn't really make sense, because if it's like x cubed and x squared, then there would have to be like something.
Okay, maybe I'll just start with x squared, right? Let's start with just the 1, right? X cubed, let's say x cubed, what would that become?
1 x to the power 4.
X to the power 4, yes, but remember, we did 2 steps before. So now if we go backward, it has to be reverse, but still 2 steps, but the reverse of these 2. So yes, Charlie is correct. We did top down. Now to go reverse,
3x to the power 4?
No. Not that.
Because that one would have had to have a 4 in front of it. It would have to be 4x cubed if the power was 4 though. So like...
But this one is 1x cubed.
Yeah, so...
So you guys are on this junction there where you want to reverse this, right? What's the reverse of timesing the power? Divide by the new power. X. Yes. Okay, this is the new part. Divide power. Right, divide by the power.
What power? Which one?
The new power, because we did it in this order, right? You plus 1 to the power, so there'll be x to the power 4. And then you divide by the power, which is divided by 4.
Okay.
Right? So it makes sense, because if you take this one, if you derive that, it would be 4 times into, drop the power by 1 over 4. 4 over 4 cancels out. So that's 1x power 3. Which is this. Right? Does it make sense?
Yeah.
Yeah? Because when you times the power down, it has to be cancelled off. Otherwise, you won't get 1 x power 3. Okay, let me show you guys another example. So let's say we start with 10x power 5. Can you guys guess what the original equation is? The antiderivative of this equation.
X 6.
X plus
power 6 over 10 over 50. I don't know.
Not quite. Over what?
Over 5.
Over the new power 6.
But where does the 10 go at the front?
It's still there. Right? Because let's say if we, I'll put this on the side, and let's say we don't see that one here. If we were to derive this one, right, we follow the forward rule, which is times the power down, so that'll be 10 times 6, and then you drop the power by 1. Alright? 10 times 6, x power 5 over 6. Once again,
Just cancel. Okay.
it cancels off. So that'll be 10 x power 5, which is that thing there. Yeah, does that make sense? So the two steps will reverse, right? You need to add the power first, and then you divide by the new power. Now, there is one thing though. So if we were to, okay, let's go back to this equation here where you get x power 4 over 4, or rather as 1/4 x power 4. Okay? If I were, actually no, I'll write it this way so you guys are used to it. If I derive this, what do I get? Well, I get x power 3. Right? We just went through that equation. Yeah?
Yeah.
Okay? This one though, x power 4 over 4 plus 10. When I derive it, what do I get?
Wait, what are we talking about?
If I have a plus 10 here when I derive this thing,
It goes away.
it goes away. So it's just x cubed. Oh, what if I have x power 4 over 4 plus 1000 when I derive that?
Disappears.
It all
So
disappears.
you can't like. You can find like the part that involves the x, but not any.
Correct. You cannot find what is the constant.
Yeah.
Which means that when you go backward from here to this side, right, you actually have to write something like this. X power 4 over 4 plus constant c. Because you don't know what a constant is, right? If there was a constant, when it's to get derived, it's gone. Right? We don't know what a constant is. And most of the time, you will need to have some more information in order to find out what a constant is. And you will see that in some of the questions from today. Okay, so now the official notation, all right, guys, have a look. The official notation for antiderivative. Derivative. So I'll write an official notation, then I'll explain what it means. The antiderivative, right? It's like an S. Okay, do not write the S. It's more of like, imagine it's like a straight line, but then it has like a curve like that, and then you slant it a little.
It's like an F.
Kind of.
No, like the one that you had to learn in like primary school.
Yeah. But the shape is like, it looks like that. Right? It's like an S, but a stretched out S. Put it that way. So the antiderivative, right? The antiderivative of let's say x to the power 3 is equals to x to the power 4 over 4. All right, and then plus c. But wait, that's not all. Okay, that is not all. You need to say when you're anti-deriving, which main variable are you anti-deriving with respect to? Remember when we derive, it's like d over dx, right? It's like deriving with respect to x. Remember that experience? Now you also need to put the dx in there somewhere, right? And you write dx after here, okay? So you write anti-derive x to the power 3 dx equals to that thing. And I'll say what notation.
You should have told me that before I wrote.
That's why you guys need to calm down and you guys have to write it. But, okay, so this thing is called the integral sign. The integral symbol. Okay, and this whole expression is called, let's say this one here. So this the symbol is called the integral symbol, and this one is called an indefinite integral.
The whole thing.
Yeah, the whole thing, like that whole expression there is an indefinite integral. So you may wonder if there's an indefinite one, there must be a definite integral, and yes, you guys will learn about the definite integral later. If there's indefinite, there will be definite, right? Fortunately, it's also part of Unit 3, so it will clear in your mind, like, oh, wow, what is the definite integral? Now, why is it called indefinite integral? The word indefinite here is because we don't know what the c is. Yeah.
So it's like a little estimation because you can find the part that involves x.
Yes, but not the constant.
Because like the number could be like way bigger than.
Yeah,
what it is.
it could be a million, it could be like 1 trillion, whatever. We don't know what that number is. That's why it's called an indefinite integral. So the answer will always have a plus c. Okay, so that's what the indefinite integral is. So I'll go through a few examples, right, and then we'll move on. So I'll go through all of the content first, and then we'll spend the second half doing some practices, so that I can cover everything before. Whoops. Yeah. Okay, let's see. What do you guys think is the answer for question A, example 1A? Anyone?
Oh, let me get my notes going.
3x to the power 6 divided by 6.
Yes, correct. And you would write it this way: antiderive of 3x power 5 with respect to x, right, is equal to 3x to the power 6 over 6 plus c. Remember, there's always a plus c. Yes, Charlie.
Because on this one, we don't have example 1. But for this one, how do you do ones that are in fractions?
Yeah, I'll get to those.
Oh.
I'll get to those in a second. The hint is you can convert it to a power. Okay?
Okay.
I may skip the easy ones then. We'll see. So then this one you need to simplify 3 and 6. So that will be x power 6 over 2 plus c. Okay? And sometimes you see the answer as 1/2 x power 6 plus c. Any question on this other version here? 1/2 x power 6 plus c. As opposed to x power 6 divided by 2. Any question?
No.
No? Makes sense, right? Just a coefficient. Okay. For question B, it's the same thing. Just write antiderive integral sign 3x squared plus 4x cubed plus 3. Remember, you gotta write what is it with respect to. So you gotta go dx at the end. Right? The integral sign always comes with a d something at the end. Dx with respect to x, or dt with respect to t, or whatnot. So if you're comfortable, you can do the thing where you add the power by 1, and then when you divide by the new power, if you see that it cancels off, you can just leave it out. So similarly, the next one, if you add the power by 1, it will be x power 4, and then when you divide by 4, it cancels this one off, so it'll just be x power 4.
So, and then would 3x just be 3x?
It will just be 3x and then plus c. And that's it. That's a simplified version. Any questions so far? All good? All good?
All good.
Okay, now let me go to the hard ones. I think you guys probably okay with these easier ones. Oh, actually, no, this one. One more example first. Example 2. So this example, I didn't include it into your sheets because I was just go through it once and you get the idea straight away. It's not that hard. But this example, it is known that, right, f dash equals to this, and then f0 equals to 0. Find fx. So this one is a little bit different. This is example 2. Have a look, guys. F dash x equals to that equation. So once again, we're given the derivative. Okay, so remember fx is the original, and when you derive it, right, when you derive it, you get f dash. Okay, if you're given f dash, in order to get back the original, you need to anti-derive. Okay, anti-derive to get back the original. So then that means I'll write it as fx, the original equation. The notation is very important. Yeah, fx is equals to the antiderivative of this thing with respect to x. Okay, so then that would be x to the power 4 over 4 plus 4 over 3, or let's say I'll write it as 4x power 3 over 3, and then plus c. Okay, so far so good, but what do we do with this information here?
Oh, wait.
f0 equals to 0. What do you guys think it will be used for?
Which are to prove that you got the right one?
No.
Find the constant.
Find the constants. Very good. So use f of 0 equals to 0. What does that mean? You sub what?
0 in as x?
Yes, x is 0, and then the f value is also 0. Okay, because f at the x value 0 is 0, which means that when I sub it in, I would get 0 equals to 0 power 4 over 4 plus 4 times 0 cubed over 3 plus c. So that would just be 0, that would just be 0, therefore c is just equals to 0, right? Which means that the function is definitely going to be x power 4 over 4 and plus 4x cubed over 3. That's it. There's no constant because the constant is 0. In the harder equations though, you will not get 0.
Well, couldn't you have just assumed that it was...
You can.
didn't have to work it out before that? Because it gave you f dash of 0 equals 0, so you didn't have to do all that working.
No, f0 equals to 0.
Oh, no, yeah, but like f0 equals 0, that means that would have to be the constant because everything has an x in it. So then you wouldn't have to do the working out, would you?
Yeah, yes, you don't have to. Okay, Charlie, so Charlie's question is like, do we really have to go through these ones? Now, the shorter form, let's say the shorter version of all of this, you would write since f0 equals to 0, comma, constant equals to 0. You can write this I've seen answers that are written like this, and if you can recognize it, you can write it, okay? But Charlie, you need to at least write this statement here. Yeah, since x0 equals to 0, comma, c equals to 0. Okay, you can write just that statement, so you don't need to like sub the values and stuff like that. Okay, but at least write that statement. Otherwise, they will consider that, oh, you forgot a constant, minus mark. Okay, all right, now let's get to the, so I think that was actually the end of it, and now let's go to the harder one. Okay, this is actually 9a, we'll skip 9a. Okay, this one. Find y in terms of x if, so now these examples are the harder examples, and these are the ones that you guys will be practicing on, not the very first one, because I think the very first chapter 9a is actually not too bad. So yeah, that's why you notice this chapter you have on your hand is actually 9b, not 9a. Okay, so how do we do something like this? Question A, dy over dx. Okay, so the derivative is 1 over x squared. Now you got to change that to power negative 2. Okay, and then you would write y is equal to the antiderivative of x to the power negative 2 with respect to x. Okay, and then when you actually antiderive that, raise the power by 1. Remember the order, you raise the power first, and then you divide by the new power, which is negative 1, and add the plus c to it. So then that would be negative 1 over x plus c. Okay, any question? No? All good? So these techniques are just about, we should close the door. They're just about changing the x expression into like some sort of power and work with it. Okay, now B and C, I will go through example 5 and 6, and then we'll move on first. Okay, so again, dy over dx is equals to, now 3 square root x is 3x to the power 1/2.
Wait, okay.
Alright, and then you would write y is equals to the antiderivative of this thing.
Going so fast, Chris.
With respect to x.
3.
Okay, I'll slow down a little bit. Any questions so far?
No.
No? Alright. When we antiderive this, now let me show you guys the algebra here. It may be a little bit tricky. So first you increase the power by 1. What's 1 over 2 plus 1?
1.5.
Yes, but I want a fraction 1.
3 over 2.
3 over 2, yes. Any question?
No.
No, easy, right? 3 over 2, and then you divide by the new
3.
power.
How do you divide by 3 over 2? Wait, wouldn't it be 3x? Yeah.
Yeah, and then plus c, right? So how do you divide by 3 over 2? Now the trick is to think of the division as, so think of it as like a division symbol. So divide by 3 over 2 is the same as?
So you're just doing 3x 3 over 2.
Times the reciprocal. Okay. Which means that this will turn into?
6x 3 over 2 over 3.
6x over 3, yes. Okay, and then times by 2 over 3. Now, if you can see that the 3 cancels out, you can actually just cancel that out first, and then plus c, of course. Then that would be 2x 3 over 2 plus c. Okay? So the tricky part of this chapter is the fractional, the rational coefficient. Rational indices. Okay, so you gotta be pretty confident with like the weird fraction operations, like plussing 1 into a fraction or dividing by a fraction.
Will the fraction ever have to be simplified, or?
You have to simplify, yes. Yeah, that's a standard procedure. Okay, so then this one, I will skip a step. I'll write y equals 2, just antiderive this. Okay, so I'll skip one step. I'll slowly start skipping a few steps to show you guys what's the shortest path that you can take. Okay, so antideriving it. Now, the same thing would be add 1 to the power. So add 1 to 3 over 4. Sarah, what's 3 over 4 plus 1? 7 over 4, that's right, 7 over 4. Okay, and then you divide by the new power. But if you can see that dividing 7 over 4 is times by 4 over 7. So you write 4 over 7 at the front. Okay, does it make sense? Mm-hmm. Okay, similarly, the next term would be you add 1 to negative 3 over 4. Charlie, what is negative 3 over 4 plus 1?
1 over 4.
Is 1 over 4, yes. So 1 over 4, you divide by that, means you times the reciprocal, and so that would just be 4x to the power 1 over 4 plus c. So you see, if you are confident enough, 2 lines and you're done. In all the intermediate steps, like the one where you write this version here, and then you write the simplification here, they get no marks. Okay, most of the time you get 1 mark for showing that it's a derivative, and then antiderivative, and 1 mark for the final answer. That's it. And then you check the plus C and stuff like that. Okay, so that's why this is the shortest path that you can take in order to get to the final answer. All right. So easy, right? So far. So far, so good. Next is example 6. So example 6 is similar to an example that I just went through earlier, where they give us a point, right? So f1 equals 3 is like saying x equals to 1 and then y equals to 3. Right? It's just to clarify any confusion, because fx is the same as y. Right? So if they give us a point, sometimes they actually give you a point like, it passes through the point 1, 3. It means the exact same thing. Okay? Passes through the point 1, 3 and f1 equals 3 or x equals 1, 1, y equals 3, exact same thing. You guys have done many of that before. So same concept. Now I'll write the shorter path. So fx is equals to antiderive of x minus 3x power half dx. Okay, and then that would be equals to raise the power by 1, which is 2, and then divide by 2. Minus, now raise the new power by 1, which is x to the power 3 over 2, and then times by the reciprocal. So that would be 6 over 3, which is just 2x. Okay, so 2x to the power of that plus c. And then we need to sub f1 equals 3. Okay, so then you will get the y value, which is fx, so that's 3 equals 2, and then 1 squared over 2, or just 1 over 2, minus 2 times 1 plus c. So you see, c is, this time you actually need to work it out. It's not that simple, right? So move the 2 over, so 5 minus 1 over 2 equals c. That'll be 10, so that'll be 9 over 2 equals to c.
Wait, why does it take 2? In the second line, why is it 2x to the power 3 over 2?
2x to the power 3 over 2?
Yeah.
Is because that one will turn into, technically is negative 3. So that would be negative 3 x to the power 3 on 2 times by 2 on 3. And then these 3 will cancel out. Alright, so I just did the simplification step in one go. But yeah, so finally, once you found the c value, you need to find the actual fx, which is then x squared over 2 minus 2x power 3 over 2 and then plus 9 over 2. So the final answer has a value for the constant. Okay. Any questions so far? Sarah, all good? Confident you can do these questions at home? Kind of. Yeah, you gotta practice. Okay. If you need help, just let me know. Whatever question. Alright. So get ready and we're moving on. Next chapter. We are going through 4 chapters today in terms of content. Cool, you guys can do this one, right? My 8 students. Here, pass it around. 9C. Okay, this is the tricky one. Chapter 9C.
Wait, why are we doing all that stuff today?
Just wait, Koi, I need to finish the last question.
Okay. Why? Because it's right before school. I need to get to this.
Fall asleep.
At school, you mean?
Over here.
Quick, can you please go up?
You can't. This is too. Yeah, it needs a lot of brain power, isn't it?
I just don't really have much of that right now.
Oh no, it's alright. Maybe the second half can be a bit more chill. Or maybe I'll reduce the amount of content. We'll see how you guys go. So until Sarah has to leave, we'll just keep on going until we finish all 4 chapters. Right?
Okay. I'm ready.
Alright, 9C, the antiderivative of... Oh, this is hard, eh? Okay. The antiderivative of... Maybe you guys will be stuck on this chapter.
Could you just please scroll up the tiniest bit, Koi?
Okay, maybe I won't go through 4 chapters today. Maybe 3 or 2. I might end up overloading you guys. Because the last 2 chapters really easy, much easier than this one. If you guys get this one, then you guys get the next 2 chapters really easily. Okay, we'll see. All right, guys. Important. Have a look at the screen if you can. The antiderivative of ax plus b to the power r. There are two scenarios. So the first one is when r is not equals to -1. And why is it -1? Well, we'll get to that in a second. And the second scenario is when r is equal to -1. Okay, so I'll show you guys what happens the standard pathway when r is not -1. Okay, so antiderivative of, let's say, ax plus b to the power, when r is not -1, let's say to the power 2, for example. Okay, now the thing is, if you guys see this equation ax plus b, what type of equation is this? What's the name of this equation, ax plus b? Just the ax plus b. Right? Is a linear. Yes, is a linear. So note that you can anti-derive functions of a linear equation. Okay? Why? Because when you derive it, okay, actually remember, I'll go to the x is not -1 first. And then let's say example. Let's say if we were to derive, right, let's say 2x plus 3, everything to the power 4. Okay? So if we were to derive this, then what will we get? Well, this is the chain rule. So you go 4 times by 2x plus 3 power 3. Yeah, and then you need to derive what's inside it, which is just 2. Okay, make sense so far?
Just wait. You're too fast, Koi. I can't process.
Okay, I'll pause a little bit. Okay, so when you derive it, it will be 4 times, it's a chain rule, right? So you derive the outer function, you get 4 times the bracket to the power 3, and then you have to derive what's inside the bracket, which is plus 2. Does that make sense?
That's like normal.
Yeah, it's a normal derivative, right? So when you anti-derive, you do the reverse, which is what? You divide by this number here. Right? Because remember, when you derive, you times, so when you anti-derive, you divide. Right? It's the opposite. Okay? So if we were to anti-derive, so this time we're not deriving, we're anti-deriving. Anti-derive a different equation. Let's say 2x plus 3 to the power 3, for example. Okay? Or let's just say 8 times. So we anti-derive this, aka we're trying to anti-derive this with respect to x, right? Then we do the same thing where we raise the power of the middle term by 1. Raise the power by 1, okay? And then it will still be 8 times that, right? Then you divide by the new power, which is 4, but that's not all.
Times by 2.
Not times by 2, you do the reverse of times by 2, which is divide by 2. So you times by 2 at the bottom. If that's what you meant, then you're correct. Yeah, so you times the 2 into the bottom, and then what does that give us? So plus c. So what does that give us? 4 times 2 is 8. It will cancel with the 8 on top. So then that turns into just 2x plus 3 to the power 4, and then plus a constant, which is like the original here. Alright, so that was a bit of a jump. But does it make sense?
Yeah.
Sarah, any question?
Is the 4 at the bottom the power?
The power, correct. Yes, this 4 is the power, yes. You divide, or you always divide by the power, the new power. Okay, so another example, right? Another example, anti-derive of, let's say, 6x plus 1, everything to the power -10. Okay, dx with respect to x. So to the power -10, first you add 1 to the power, that would be plus 1 to the power -9, right? And then you divide by the new power of -9. And you also have to divide by the coefficient of x. Does that make sense?
Yeah.
Yeah? So remember, when you anti-derive, you normally have to divide by a bunch of stuff. Okay? At least divide by the new power. Okay, so then this one would be just, the -9 times 6 is negative. So that will be -1 over 54 brackets 6x plus 1 to the power 9. Just to keep the power positive. It will look something like that. Okay? Plus c. Got a plus c here. Okay, now let me tell you guys what happens when the power r is equals to -1. Okay, when the power is equals to -1 for ax plus b, everything to the power r. Okay, so when it is equals to -1. Example, 3x plus 2 to the power -1. Okay, so let's say we don't know what it is and we just anti-derive it as usual. We're naively just like, okay, we add 1 to the power and -1 plus 1 is 0. And then you divide by the new power, 0. Bam, the whole thing falls apart. In math, you can't divide by 0. That's the only thing that, regardless of what level you learn, you cannot divide by 0. Maybe in some strange number systems you can, but no, most of the time, when you see divide by 0, something is very wrong. Okay, and that is why that doesn't make sense. Okay, so when the power is -1, when you add 1 to the power, you get 0, and then you have to divide by that number. You can't divide by 0. Therefore, this is not the way to go. But do you remember there was one equation, right? When you derive what equation, the answer equals to 1 over x. Do you remember that?
The ln.
Yes, when you derive ln of x. And then you get the answer would be 1 over x, which is x to the power minus 1. So you see, when the power is -1, when you anti-derive that, you go backward, you would get ln of the function. But remember, when you get a function of a linear equation of x, you always need to divide by the coefficient of x, which is 3 in this case. And then you go plus c. Right, does it make sense? Yeah? Because why is that the case? Well, if we were to take this thing, and then we derive it, let's say we try to derive it over here. Okay? ln, so first 1 over 3, we leave 1 over 3 out. Right? And then ln becomes 1 over the function, right? And then you derive the inner function, which is 3x plus 2, then you times it by 3, and c is gone. So you see, suddenly the 1/3 and the 3 will cancel out. So the answer is just 1 over 3x plus 2, which is the original equation here. Okay? So that's why when you have a function of a linear function of x, like ax plus b, see that form? This is a linear function of x. If you have a function of a linear function, you need to divide by the coefficient.
It's not to the power of 0 though.
No, it's not to the power of 0. So it's a special rule. So that's why now I will give you guys the formal rules, right? So when you anti-derive, let's say ax plus b to the power r, where r dx, where r is not equals to -1. Anything but -1. Okay, anything but -1, even like a negative fraction, you can still do it using the normal rule. So the answer would be ax plus b to the power of, you add 1 to the power, right? And then you divide by the new power, but you also divide by the coefficient of x.
Yeah.
Okay, so that's rule number 1. Number 2, when you anti-derive something that looks similar, but the power, so dx, but the power r is equals to -1, then the answer will be ln of ax plus b to the power, that's it, just ln of ax plus b, and then you need to divide by the coefficient of x, which is a. Right? And of course there's a plus c.
Like, we add 1 to the r at the top, but then for this one, how come we don't add 1 to the r, to, like, in the power?
Because if you add 1 to it, you get 0.
But then, like, how did they decide? Because, like,
so
you know what I mean? Like,
yeah, so it comes from the main rule that when you derive ln x, you get 1 over x, which is x to the power minus 1. So it comes from the main rule that when you derive ln x, you get x power minus 1. So when you anti-derive this thing, you must get back ln x, right?
Okay.
Yeah, like the power, the add 1 to the power thing is me showing you guys when you see that in your answer, like, wait, am I dividing by 0? Wait, that means it's something else. What is that something else? Well, it's ln.
Yeah.
Okay, so students have made that mistake many times in the past,
So
where
it's
they
like
ask.
using the different set of rules that we learned recently, not
Correct.
the product rule. It's using
No,
like the log.
yeah, the log rule. The next 2 chapters, if you guys get this, the next 2 chapters will be easy. It's just exponential, e power x, and then sine and cos. Not that hard. Okay, the next 2 chapters not that hard. The practice will take some time for you guys to get used to, but the main concept is not hard.
Go to the first rule.
It's all in the formula.
Yeah, I'm writing it down.
Yeah. I just write in a slightly different way from the formula. So if you want to write down these rules, you probably should get 2 pens, 2 different colored pens, and follow my colorization. Because you can focus on what's the difference between these rules. Okay. Yeah, actually, I think I've given you guys enough examples. Like these ones are some basic examples of how to anti-derive these. Yeah, and the examples are no, it's the same. So we'll move on first. Go through everything first, okay, and then you guys get a chance to practice later. Next, 9D. So note that these sheets is like, I don't know, like a page and maybe a bit more than that. It's not much. That's why I'm confident you guys can go through 4 chapters today, because these chapters are not that. There's not much more content to go through. But the practice though, you have to be a bit confused in the practice, I'm sure. But that's okay. That's just normal. So I actually want you guys to be confused now than later. Right? Because if you guys do one topic at school one at a time, like I'm worried that like before, like when you move on to the next one, because you remember the last one so much, you get confused, with the previous chapter. That's why I'm throwing all the concepts, and then you got to get very confused doing these chapters first. When you're like, oh, is it this rule? Is it that rule? But when you're used to it, you'll be able to handle the exam. Because in the exam, you see an equation and you don't know what rule it is to apply. Okay, so that's why we're going through all of these. Now, the rule for this is actually really simple. When you anti-derive, I'll go straight to the rule. When you anti-derive e to the power, right, ax plus b. So when e is raised to a, note that this is a linear function of x. Okay, e to the power ax plus b dx. When you anti-derive this, the answer, remember when you derive it, you get the same thing. So when you anti-derive it, you also first just get the exact same thing, but you do something else to this. What do? Remember, when you have a function of a linear function of x, you always have to divide by the coefficient of x. Yeah, and then you plus c.
So we're not doing, because like if we had like e to the power of like 2x squared, would you have to add to that power?
You can't anti-derive it. Yeah, that one is something you actually can't anti-derive. Not in math methods. There are some other ways of doing it, but it's not the straightforward pathway. Yeah, so I don't think you guys have to learn that. So you only need to worry mostly about a e to the power linear function, not squared, not cubed, not nothing. It's just linear, ax plus b. Alright, so some examples of this form.
You could derive it to get like e, like whatever it is.
Correct, but you can't anti-derive it.
Okay.
It's not straightforward. Yeah, so when you anti-derive e to the power 2x plus 3, it will be the same thing, right? E to the power same thing, and then you divide by the new power 2 plus c. Okay, so these are some examples. So this is something that follows a rule. Sometimes you get something that doesn't follow the rule. What's antiderivative of e power x?
E to the power of x.
Yeah.
Plus c. Then yes, that's correct. Okay, pretty easy, right? And that's why if you guys are comfortable with e, like the concept of the exponential equation, base e, the derivative and antiderivative is really easy, right? Because when you antiderive or derive, the e to power whatever, it stays exactly the same. That's why it's a special number. Euler's number is a special number. But e to the power 2x would be the same thing, doesn't change, and then you divide by the coefficient of x.
Okay.
Okay? If there's no constant like b, it's fine. Just don't worry about it. All right. Yeah. So similarly, if you have antiderive of e to the power negative x, well, again, you just keep the exact same function and then you divide by -1, and then plus c, which is then just negative e to the power negative x plus c. Okay? Alright, easy enough? Alright, let me go.
The negative.
Because you divide by the coefficient of x.
In example 10, like we did one where it was like e to the power of like 2x plus 2, but it was all in the power. But what if you had like e to the power of 5x and then
it will be similar to this
6x.
example
like,
here.
Do you derive the 6x as well?
Yes, separately.
Okay.
Yeah, as a separate term, because it's a separate term. Yeah, so I'm just showing deriving, anti-deriving term by term. So when you anti-derive or when you integrate, I think you antiderive. So when you antiderive like multiple terms, it's just simply each of them one by one. So if you go to antiderive e power 5x and then plus 6x dx, right? So you antiderive the first term, which is going to be 1 over 5 e power 5x, and then you antiderive the second term, which is plus 6x squared over 2. Okay, any question?
Okay.
Yeah, Blake?
I'm just processing.
So this one, when you antiderive, becomes this thing. And then this one, when you antiderive, becomes this thing.
How does it become 1 over 5?
Sorry?
How does it become 1 over 5?
Because e power 5x over 5, I can take it out as a separate, the coefficient is just 1 over 5 times by e power 5x. It's the same. So when you have a whole number, you can just times it to the top, which means you can also split that away from the top and write it as a coefficient. Right, any other question?
No.
No. Okay, we'll go through example 11. Because I think this one is probably good to show you guys an actual application of this. All right, example 11. If the gradient of the tangent at a point is given by this and the curve passes through the point 0, 7.5, find the equation of the curve. So when you see gradient of the tangent, you think about derivative, yeah. So they're just saying the derivative is equals to 5e power 2x. So you would write the first information as the derivative, right, is equal to 5e to the power 2x. Okay? Or you can write it as y dash, right? Because they say xy, so you can write y dash is equals to 5e power 2x. And then you just gotta, they ask you to find the equation, which is y in terms of x. So you gotta write y equals to antiderive of this thing. All right, because you're given the derivative, so you get antiderive to get the original. And when you antiderive it, it will be 5 over 2 e to the power 2x plus c. Okay, and then it passes through the point 0.075. This is what I said earlier, where they can phrase like the substitution in many ways, right? But passing through a point is the same as sub x equals to, or you can just write sub 0, 7.5. Okay, so x equals to 0, and then y equals to 7.5. So we put 7.5 is equals to 5 over 2 e to the power 0 plus c. E to the power 0 is 1. So 7.5 is 15 over 2 equals to 5 over 2 plus c. Then you put that over there, 10 over 2 equals... Yeah?
Where'd you get 15 over 2 from?
Oh, that's 7.5.
Okay.
Alright? Yeah? Because when you times it, 7.5 over 1, you times top and bottom by 2, you get 15 on the top and 2 at the bottom. So it's 15 over 2 equals that, so 10 over 2 equals c, so 5 equals c, which means that y is e. So therefore, y is equals to 5 over 2.
Wait, I'm confused on how you got 15 over 2 actually.
Which one?
How you got 15 over 2.
Oh, okay.
I know, it's timing it all way.
Right?
Yeah.
And then, how did I get this? Okay. Times the top and bottom by 2.
Yeah, but why?
Because, well, when I see 0.5, it's just an odd number divided by 2. Or you can times both top and bottom by 10. Then you get 75 over 10 and you simplify. But that's
Were you
that's
just
wrong.
trying to get rid of it being a decimal?
Yes.
But then don't you have to do what you do to that side to the other side?
No, because the other side is already 5 over 2. That's why I changed it to a fraction. Right? Because if we leave it, I leave this one as a decimal, not changing it to 5 over 2 or 15 over 2, then I'll need to convert this one to a decimal, which is 2.5. You can work with it, but I just prefer writing it in the fraction form.
But then don't you have different values on... no.
Yeah, make sense?
Yeah.
Sarah, make sense?
If it's like on one side of the equal sign, you don't have to like make it the like what you do to one side, do the other side on the other side of the equal sign. Because now I'm confused.
Which line? You mean this line or the one before?
Yeah, when you change 7.5 to 15 over 2, you don't have to do that to the other side because it's on the other side of the equal
Because okay, and yes, I get your question. Because we are changing a single number, so it's like finding an equivalent of this, and then you erase that, you replace that with the equivalent.
Yeah, that's what confused me. Once I realized.
Yeah.
It's the equivalent.
Yeah, it's like saying 10 over 2 is equivalent to 5, so you're not changing anything. You're just changing that number to an equivalent, and the number is 7.5. So you're changing that to equivalent, and we write it as 7.5 over 1. Then you time, if you can recognize that, times top and bottom by 2. The top will just be 15, and the bottom will just be 2. Yeah. Does that answer your question? Yeah. So yeah, so that's how you get like a question like that done. Right, that's it. That's the only example. There's actually a I think it's actually like a somewhat of a complex familiar. No, not really. It's still a simple familiar one. Okay, so far so good. Yeah. Next, we can go through 4 chapters after all. Not too shabby, guys. Not too shabby. Yeah. Take your sheet for 9E. I will wait for Charlie to come back. So it's just the trigonometric function. This is like the shortest one. The back doesn't even have anything. Yeah, so this is actually the shortest one. The concept is actually really easy. I'll show you guys first, and then you guys can even get started with the question. I'm sure Charlie can follow in no time. Okay. So 9E. This is the one of the, I think these chapters are one of like the easiest chapters. If you get the main concept, you can actually do all of these questions. Now, in saying that, Unit 3 of Math Method is harder than Unit 2, and the reason why it is harder than Unit 2 is actually because of what happens after these easy chapters. You gotta combine all of them to do a bunch of very difficult questions and new difficult concepts. Okay? And that's chapter 10. Alright? Chapter 10 is the last chapter of Unit 3 and the hardest chapter of Unit 3.
Which one? Chapter 10?
Chapter 10, yes. That's the last one. So chapter 3, Unit 3 only has chapter 6, 8, 9, 10. Right? And by the end of today, we're halfway through chapter 9, or more like 2/3, almost 80% through chapter 9. Next week, I will touch on the last 2 chapters in chapter 9, which is algebraically difficult, but the concept's not too hard. Yeah, but algebraically is a little bit difficult. So I'll go through those ones, and then the week after, I'll start on chapter 10, and when we finish chapter 10, you're actually done with Unit 3. So you're done with Unit 3 even like way before your school is like halfway through Unit 3. Okay, so the goal for you guys is to do way more practices than a normal student. You need to get to the point where every question in the textbook, you can do it, because you guys are very, very ahead. This is one of the few times that I get to have a class that is so ahead of school that I can get you guys to do complex familiar questions or complex unfamiliar questions for homework. But yeah, anyway, Charlie, what you missed is basically we're moving on.
Okay.
Right, to 9E. And then next week we'll finish chapter 9 with the harder chapters, not too hard, and then we'll move on to chapter 10, which is the last chapter of Unit 3. So you guys are reaching somewhat the end of Unit 3 already.
Wow.
Kind of. Okay, so pretty far ahead. Anyway, chapter 9E is just antiderivative of trigonometry function. So remember when you get the when you get the original function, so fx, right, and then f dash x. If you get the original is sine x, what's the derivative?
Cos.
Yeah.
Cos, yes, right? When you get cos x, what's the derivative?
Negative sine.
Negative sine x. Now, if you have sine of ax plus b, what's the derivative?
Sine
Right.
of ax plus b.
Yep.
A cos ax plus b.
Yes, correct. It's a, right? Because when you derive the inner function, you get just a, and then a cos ax plus b, right? So when you have cos of ax plus b, when you derive it, you get
Negative a sine.
negative a, yes, sine of ax plus b. So far, you guys are very comfortable with the derivative, right? Now we go the backward direction. So when you have sine x as the derivative, what's the original?
Well, Well, wouldn't it be negative sign then?
Negative cos x plus c.
But I thought it doesn't start off as negative cos x.
No, but then
Doesn't it usually start as like cos x and then you go to sin it?
yes. So cos goes to negative sign.
Yeah.
So positive sign goes to negative cos.
If you're anti-deriving.
Yes.
Okay. And then if you had,
Cos x.
it would just go to sin x.
Yes. If you have just cos x, when you go backward, then it is just sin x
Okay.
plus c. Yeah, because sine gets you cos, so cos gets you back sine. But if you get positive sine, when you anti-derive, you get negative cos. Because when you derive cos, you get negative sine. So these two lines are actually equivalent to each other. The two blue lines, they're equivalent to each other. Alright, so these two lines are the ones that you need to be able to connect. Alright, that's the only part that's tricky about trigonometry, is that when you derive and anti-derive, you might miss, which one gets me like negative again? That's where you make the mistake in the exam. So we've got to finish this early. You guys need to do a mixture of derivative and anti-derivative question, because that's what the exam will be like. You see some question derive, some question anti-derive. If you mix that up, GG, you lose the entire question, 0 marks. Okay? But of course, I'll get you guys to the point where you're not comfortable with that. So now, if you have sine of ax plus b, okay, when you anti-derive it, what do you get?
Negative cos plus c divided by a.
Yeah, that's right. Divided by a, and then you plus c outside of it. Yeah. Right? Any question? Charlie?
I don't think so.
Sarah? Yeah. Okay, and the last thing is obviously antiderive of cos ax plus b, and that will just give you positive sine ax plus b over a, and then plus c. Okay, so this is a table, well, this is a very short table to show you guys like the relationship between these expressions, but the main rules are these ones. Antiderive sine, or we start with cos of ax plus b, right, with respect to x, would be sine of ax plus b, and then you divide by a, then you plus c. Okay, second rule, then the last rule for this chapter, is antiderive sine of a linear function. Note that we always see just a linear function, yeah, ax plus b. If it's not a linear function, you can't. Sorry,
I thought we just did that one.
yeah. So I'm just running it as a main official two rules that you need to remember. So minus cos of ax plus b, and then over a plus c. Okay, so these are the two rules for this chapter. That's it. The rest of it you guys should be able to do. Okay, or at least get started, and then when you get to some algebra parts, you may get stuck, but we'll see. Okay. Now we'll do the questions in the reverse order. So we are at E now, but we have to flip all the way back to B. Alright, let's try the questions from B first. Alright, let's start in 9B.
Wait.
Four chapters. Got an hour and a half. 9B. Let's see. I'll pick what question for you guys to do. Let's start with 9B, and the question will be question 1. (2D) and question 3AB. Okay, so highlight these ones. So 1 ABC, 2D, and 3AB. Actually, maybe I'll just give you guys all of the minimum questions to do first, because I think next week we'll do a bit of practice on these chapters before we move on.
I'm confused on question 1.
Question 1a,
Yeah.
you have to convert it to power -3.
But why, like, I know, like the question, like find y in terms of x.
Oh, so they give you...
Find y, the antiderivatives.
Yeah,
Yeah.
so the antiderivative, yeah.
So y equals the antiderivative of
Yep.
x to the power -3
Yep.
dx. And that's it?
Yeah.
Yeah. Wait, which one are we doing?
For 9b, here, I have a list on the screen here.
Why are the answers so different? Why am I getting them so wrong?
Shouldn't be. Sometimes it might just move the powers around to make it positive power and stuff like that.
So it'd be, for question 1b, it'd be 3 over 2 times 4 x to the power 3 over 2, right?
2 over 3 times 4. That's when you enter the right, you
yeah,
divide. Yeah.
But then you get, I got 8 over 3.
Yeah.
But
Proceed.
yeah, but it's different to the answer. The answer got 3x to the power of...
Oh, yeah. You times 3 over 4. You got 12 over 4. Right? Because the power is 1 over 3, and then we add 1 is 4 over 3.
Right.
Right.
So I've got that.
Cube
And
root.
then-
Cube root. That's 1 over 3.
Is it
Cube root, yes. Root 3 of x.
just...
Yeah, it is root 3 of x.
I didn't see it.
Yeah, so when you do root 3 of x, you will get just 3. Alright, so these are the list of questions that you guys will need to do as a bare minimum for this week. Okay, so Sarah, you can have go back and try out these ones. Now, depending on how everyone goes in the second half, so now I'll just go around and help you guys. So these questions are not hard, but in the second half, if there's time, I'll go through some harder questions. I'll record them for you. Right? It will be part of the same recording, so it's all in one place.